Okay, now solving linear inequalities and then putting them in linear inequality systems. This just means we're going to solve more than one. It's just like when we have a system of equations. We're going to have a linear system of inequalities. And really, the best way to solve it graphically. So that's the way we're going to solve these. Alright, so in order to solve a linear inequality graphically, what you do is, well, the first thing, and ours will always be equal to, so the line will always be included, so it'll always be a solid line. Remember from algebra, if it was included, it was solid. If it wasn't included, it was a dashed line. But like I said, ours will always be included, so it's always a solid line. So that's the first thing you do. Graph the line because that's part of the solution, and it's also the boundary. One side of the line is the solution set, and one side is the false set that we want to block out. Step 2, then figure out which side we want to do that in. Half of the plane, so either the plane above the line or the plane below the line, represents the rest of the solutions. So you pick a test point, and really, you only have to pick one. It's always a good rule of thumb to pick two. Pick one in both regions so that you're sure. But technically speaking, you only have to pick one. And after I do a few of these, I typically only end up testing one point. But the first few, I'll test both because it's just a good thing. If you want to make sure you're shading the right side, testing a point on both sides where one is true and one is false. And it should come out that way. One side should be true and one side should be false. And remember, the true side is the part we're going to leave blank. That's the solution set. The false side we're going to block out. So we're going to block out the unwanted region. So the solution set is the line, the boundary, and all of the unshaded parts. And the reason why we do that in this class, and the reason why we set it up this way, is because we're going to get multiple lines together, and when we start shading in multiple lines, it gets a little messy if we don't, if we do it the other way. But it's perfectly fine. So if you're doing this at home and doing it on your paper and you're siding in like you do in algebra class, it's not wrong to do that. We just prefer this method. We find it less confusing for students. Alright, so the first example. I want to find the solution set where the equation 2x plus y is greater than 0. So the first thing we do is we graph the 2x plus y equals 0. And I typically use my zeros. I typically use my zeros. Oh, this one will be only through the origin. So if I plug 0 in for x, I get 0 out for y. And so I need another point. And so if I put in, 2 for x, so x equals 2, then y is going to come out negative 4, right? I get 2 times 2 plus y equals 0. That's going to be 4 plus y equals 0. Y equals negative 4. So scratch work off to the side. So my second point, right, we need at least 2 points to graph a line. So my second point is the point 2, negative 4. Right, you could pick a different point, different values. Those are the two that I'm going to use. And typically when we're in class, I will have a straight edge, and I encourage you to have a straight edge. I don't, so bear with my lines. They may not be the most prettiest things, because on my tablet I can't necessarily graph the best looking line. Alright, so 0, 0, so it goes through 0, 0, and it goes through 2, negative 4. And then I'm going to draw the line as straight as I possibly can on my tablet. Alright, so there is my line. There's the line 2x plus y equals 0, which is a part of my solution. Then I just have to figure out, do I shade to the left of this line, or do I shade to the right side? So I just shade over here. And so I pick a point on each side. 0, 0 I can't pick because it's on my line. So I'm going to pick maybe, when I do my testing, I'll pick negative 2, 0. So that's the one on this side. And so remember, I go and plug it in the original. So I plug negative 2 in for x and 0 for y. So I get 2 times negative 2 plus 0. And so I get negative 4 greater than 0. And that's false. Alright, so that's the false side. So I probably want to shade that side in, but I'm going to test the second point. So I'm going to test one over here. So I'm just going to pick the positive version of it. It's just easy to do. And so plug 2 in. So I get 2 times 2 plus 0 greater than, and so it comes out positive 4. And that's true. Alright, so this side's my true side. This side's my false side. So remember, I want to block out my false side. So this is the side I don't want. Alright, so this is the false. Alright, I don't want any of this. On the open side, or the side to the right, this is my solution set. So we leave the blue line, and then the side without being, right, this is the blocked out stuff. Over here is my solution. This is the solution set. Right, I pick any point on that line and it makes my equation, makes my equation true. That's another example. Alright, so this one's a simple y, but sometimes it's the simple ones that are hard. Y is less than 4. So the first thing it is a line. It's the line y equals 4. I've got a graph, so this is my special horizontal line, y equals 4, meaning, right, y is always going to be 4. X can be anything I want it to be. Again, goes through 0, 4, 2, 4, or any value of 4. And so it's that horizontal line where my y is 4. So there is the boundary. Y equals 4. And then I want to find the side where y is less than or equal to 4. This one's a little easier. You probably don't even need test points for it. But if I picked a test point, suppose I picked a 0, 0. Well, if I plug 0 in for y, 0 is less than or equal to 4. Right? Every single y value on this side, the below side, is less than 4. Every single y value on the above side is greater. Right? If I pick another point on this side as a test point, I pick the point 0, 6. Alright, well I plug in 6. And so 6 less than or equal to 4, well that's false. Right? And so this is the false side. Right? So I shade this in. I don't want anything on this side. This is false. On this side is my set. My solution set is on the side where it's not shaded in. Alright, so everything, I want the blue line and everything less than it, right? Because y is 4 on my blue line, and all of the y values below my blue line, any y value, if I pick any point down here, right, this would be the point -7, -1, right? The y value is less than 4. Any point on this side, the y value is less than 4. I pick any point I want. This would be the point 2, 2, right? The y value is less than 4. Every single point, there's infinitely many because it's shooting off in left, right, and down to infinity. There are infinitely many points on that line, or infinitely many points on the line, there are, that are 4, and then there are infinitely many points below the line that are less than 4, where y is less than 4. Right, next example, which actually, when we get to applications, we'll want the exact opposite of this. X is less than or equal to 0. A lot of our applications will want x is greater than or equal to 0. Alright, first thing though, we want to graph x equals 0, which x equals 0 is a vertical line, where all my x values are 0. It's actually a very special line on our graph. Right, all the x values are 0, so 0, 0, 0, 2, 0, 3, and so on are all on this line. So 0, 0, 0, 2, 0, 3, and so if you'll notice, every single one of those is on the y-axis. Alright, so it's this line, and I'm just going to kind of go over in blue here. Oops. Alright, the y-axis is the line x equals 0. So every point on that y-axis makes that true. And then I want all of the x values that are less than 0. Right? Well, which side of the axis are the x values 0? The x values are 0. Again, you don't really need tests in this point. If I pick any point on this side, alright, my x values are all negative, right? Shooting off to negative infinity. And so this side is true. If I pick any point on this side's false because all of my x values are positive. And so this is the false side, as my x values are greater than 0 on this side, right? This is shooting off, so 2 is a positive, 4 is a positive, 6 is a positive. If I pick any point on this side, it's a positive x value. And if I pick any point on this side, it's a negative x value. And remember, I want to keep the negatives. I want to block out the positive. So this is the side I want to block out. I don't want this side. Alright, so the blue line and everything to the left of it solves this inequality. And if I pick any point on the blue line, it's equal to 0, x is equal to 0. And if I pick any point on this side of the blue line, my x value is less than 0, right? This is the x value, -5, 4, right? My x value is -5, that's less than 0. That's a solution. Alright, the next one, so this is the last one we're going to do in this particular video, is basically I'm getting to the system. Alright, so if you'll notice, these are the three that I graphed individually in all the previous ones that we did on this video. I started out with the very first one, 2x plus y is greater than 0, and then these were the last two that I did. And so what I'm going to do is this is now going to be a system. Meaning I've got all three of those inequalities, and I want to find, are there any x and y values that are in this system? Right, meaning any x and y values that are on the line or are greater than the line, 2x plus y, where my y values are less than 4 and my x values are less than 0. And so how we do that is, well, first of all, we graph all the lines. So these are the same ones we did before. So graph all three lines. And then again, shade in the side that's false, right? Shade the false side. But this is the one we did earlier. So the very first one was this one. So I want to graph this and shade in that side to the left. All right, so the points that I used to graph it were 0, 0, 2, 4. All right, 0, 0, 2, 4. 0, 0, 2, 4. All right, so again, I'm going to try to graph it as best. Oh, I did negative 2. And it's not working. No. Come on. I think I made my, Alright, this one's going to come out really wonky. And hopefully you have a straight edge. Alright, so there's my blue line, which represents the 2x plus y equals 0. And remember, we shaded to the left of this. So I'm going to go ahead and shade to the left, because that's part of the solution set that solves the first equation. I need to make my graphs not so big. My next examples. Alright, I have a different color for the next one. So I'm going to graph this one in red. So my y equals 4, remember, goes through the line here. Y equals 4. And I want everything less than 4, so I shaded in everything greater than 4. So the side I want to shade in was above that, right? That was the one we did earlier. So I shade that in. None of that's part of my solution set. Right, then the last one, I'm going to do in green, which was the x equals 0, which remember is the y-axis here. Right, the y-axis. Try to make it green. That was my x equals 0. And remember, we shaded the positive side, right? I want to keep the negative, shade the positive. And so we shade in the side to the right on this one. Right of the green one now. That's what I'm shading. I'm shading to the right of the green one. So it's putting the three graphs that I did before all together in one system. And so if you look, I got a little overzealous here in my shading. There is a small region that's left unshaded. Remember, hit my clear button. Remember, we're blocking out the non-solutions, right? The false parts. The parts that are staying clear are the true parts. And so this one does have a small region, but it does have a region here, and I'm going to highlight it. Everything on this triangular part, including the edges, and then everything in between is a point. So if I pick a point on any of those lines on those edges, it makes all three equations true, all three inequalities true. So that point, this point, any of these points, actually, and any of the fraction ones, I can select in this sort of, again, it's unshaded, so if I re-erase that, it's the unshaded part. Every point in this triangular piece, including the edges are also part of it, solves the system. And so that unshaded region is the solution set. Alright, that's the solution set, is the unshaded region. Alright, we're going to practice that in a few more examples. And so like I said, this piece, this last sort of thing from this video was putting together all of the, so this is why you could technically do it the other way where you shade the right side, and then what happens is the solution set's the one that's the most shaded. Alright, but sometimes that's hard to tell, and so we prefer this method in this class. But again, like I said, if you use the other method, if you remember the other method from algebra, perfectly fine to do that. You may use it, and that's fine. Just make sure, again, you can always get down to the right area. That's the area you're looking for. Alright, stop there. We'll practice some more of these in the next video.